So this is the next conic section, so it's ellipses. So here's first a geometric definition of an ellipse. So basically an ellipse is a set of all points in the plane where the sum of whose distances from two fixed points, f1 and f2, called the foci or the foci, is constant. So here, basically, you've kind of have seen ellipses before, I think. Um, so you basically have like an elongated circle. So you don't quite have a circle. Now it's kind of more oval-like. So basically what's happening here is that there's 2 points within the ellipse. It's not actually on the ellipse. And the sum of these two distances is constant. Okay, so here's distance 1 and here's distance 2. So the sum of the distances is constant. So that means that whatever point I choose on this ellipse, so let's say I chose this point, then from the two foci, okay, so let's say this is F1 and F2, F1 and F2, so these are what we call the foci. The distances are always going to be constant. They're always going to be the same exact number. Okay, so that's basically what it is. And we'll later on figure out that that number is actually 2 times a. Okay, so just a couple things about an ellipse. An ellipse can either be horizontal or vertical. It really just depends on like how large one side is respect to the other. So this is the center of the ellipse. So here's the center. So it's centered here at the origin. Again, like the parabola, we're going to center it everything at the origin. Then you have these two foci, or two focuses. So we don't say focuses, we say foci. So there you have a focus 1, focus 2, and then you have that. Wherever it's longer is what we're going to call the vertices. So this is vertices, or vertex. There's 2 of them. So wherever it's going to be longer. So this longer side is what we're going to call the major axis. And then the smaller side is what we're going to call the minor axis. Okay, so the vertices themselves are always going to be along the major axis. Okay, so wherever the major axis is, that's where it's going to be at. Now you're going to have some ellipses that maybe look like this, where now in this case, the major axis is up here. And the foci are going to be along the y-axis. Okay, so it really just depends. So the foci and the vertices are always going to be along the major axis, and the minor axis is the lame one. Okay, so let me tell you a couple of equations about the ellipses. So ellipses with center at the origin. So feel free to copy this down if you'd like. So basically, ellipses have the following equation. So it's kind of like an equation of a circle where it's x squared plus y squared equals 1. But now everything is divided by a factor. So a squared over the x, b squared over the y. Same thing here. You can have the b and the a on the other side. It really just depends. So basically, this is if you have a horizontal ellipse. So maybe I can say horizontal. And here is if you have a vertical ellipse. So if you want to just give you an idea. So you can see that the value of a here is bigger. So that means it's going to be bigger on the y-axis. This was going to be bigger on the x-axis. Okay. The vertices, notice that they basically are the same. They just swap position. So this is along the x and this is along the y. And I said y, it's going to be on the x and the y because it's the equation. The major axis, here the major axis is going to be horizontal. So the length is going to be 2a. That kind of makes sense, right? Because if it's a on this side, it's going to be a on the other side as well. That gets to be 2a. The here is going to be vertical because if it's a on this side, then it's going to be a on the other side. So it's swapped. Minor axis, so it's probably the opposites. Now the foci, the equation of the foci is going to be plus or minus c, so wherever c may be. So if I have an equation of an ellipse, so let's say this is my equation of the ellipse, and let's say this is going to be where it's divided in the middle, then these points are just going to be c. And c is going to be the distance from these 2 points. Now, this is basically the formula on how you find C. I'll explain why it's C squared equals A squared minus B squared, not plus. And here I just basically gave you the graph. So the graph, the way that you do it is that on the major axis, whichever one is bigger. So let's say, for example, so for this particular equation you had, let me do it down here. So let's say, for example, you had x squared over 25 plus y squared over 4 is equal to 1. Okay, so this is an equation of an ellipse because it has a 1 on the other side. It should always have a 1. You have a sum in the inside of the sum of 2 squares, and then you have an a squared and a b squared. So notice here in this case, along the x-axis, this guy is going to be your a. So here, a squared is equal to what? 25. So the value of a is going to be equal to 5. In this case, b squared is equal to 4. So when I take the square root, b is going to be equal to 2. So when you graph this guy, you're going to go starting at the origin. Notice that you're at the origin. There's no movement. Now you're going to go 5 units over. 1, 2, 3, 4, 5. Along the x-axis because that's what the variable is on top of the 25. 1, 2, 3, 4, 5. So this is going to be 5 units that way. And then about the b is going to be 2 and the y-axis. So 1, 2, and then 1, 2. And all you got to do to graph this guy is just basically just trace out the ellipse. So this would be the ellipse. Okay, so that's kind of how you would graph it. Now, let me explain to you why is it that the equation of the foci is this. Okay, so why is the equation of the foci that? So basically what we're going to do a little bit of geometry. So y is foci. C squared equals a squared minus b squared. So why is that true? So we're going to start off with an ellipse. So let's start off by just drawing a general ellipse. And here's my ellipse. So here's going to be negative a, here is negative b, here is b. And what we want to figure out is what is c going to be. Here's negative c and here is c. Okay, so we want to figure out what are these points? How far away is it? So the first thing to kind of notice is that one thing that we can do is we can just form a triangle right here. From here to here. This is going to form a 90-degree angle. So notice that the sum between two distances, so these distances, the sum of these two distances should equal to a particular constant if this is really an ellipse. That's just by the definition. So what we're going to do first is we want to figure out, okay, well, what actually is this constant? If when I take the sum of the two distances, I get a constant, what is that constant? Okay, so what I'm going to do is I'm going to pick this point right here. Okay, so what that means is that the sum of the foci, so from here to here, this distance 1 is going to be the same exact distance as this distance. Let me color it in something different. As this distance. Uh-oh. It's going to be the same exact distance as this guy. Well, notice that you have this part and then this part. Well, isn't this part right here, this purple one, let me make it in purple. Okay, so we have this red part. And then you have this purple part. But isn't this purple part just the same thing as this purple part? Right? Because essentially, they're basically symmetrical, right? So this purple part is basically the same thing as this purple part. Well, if I add this purple part and I add this red part, what am I going to get? Well, isn't that the whole length of the major axis? Yeah, so the whole length is 2a. So that means that if I wanted to figure out this point, I know what the constant is now. It's 2a. Since this is symmetrical to this, that means this should be a and this should be a, because a plus a should give me 2a. So what that means now is that I can kind of figure this out now. So if this is a, this guy is c, and this guy from here to here is b, well, I can just use Pythagorean theorem. C squared plus b squared equals a squared. Since we're solving for the value of c, let's move the b over. So you get c squared equals a squared minus b squared. Okay, so that's basically what it is. Or you can just write c is equal to the square root of a squared minus b squared. Okay, you can write plus or minus also. So this is basically where the equation comes from. Okay, so that's where the equation of the foci comes from. So that's, I think, the only thing that was not very obvious. So now let's do a couple of examples to give you a little gist of all of this. So let's do these examples. Go to a new page. So let's say we are given the equation of the ellipse, and it's x squared over 25 plus y squared over 9 is equal to 1. And what I want to find the vertices. Okay, so obviously along the major axis. I want to figure out the foci. I want to find out the length of the major and minor axes. And then I want to sketch. Okay, so I want to find all of that. So what you want to do is, let's start off by looking at this, maybe just graphing it. I think graphing it is actually the easiest problem. So you can see that when I'm graphing it in the x direction, you're going to be, this is basically the longest one. So this is a, so this is a squared. So a is going to be 5. Okay, so on the y-axis is going to be, on the x-axis is going to be 5. On the x-axis, this is b squared. So this is going to be 3. Okay, so that's what that is. So the equation or the graph kind of looks like this. Okay, cool. Okay, so that's the graph. Notice that it's centered at 0, 0. Okay, so what are the vertices? Well, the vertices are just going to be the ones on the major axis. So this is the longest side. So it's just going to be negative 5, 0 and 5, 0. Okay. What about the foci? So the foci is going to be c squared equals a squared minus b squared. So c squared, I don't know what that is. I know what a is. That's going to be this 5 squared. I know what b is. That's this 3 squared. So c squared equals 25 minus 9, which is going to give me 16. So c equals plus or minus 4. So that means that along this side, the foci are going to be right there. So it's going to be negative 4, 0 and 4, 0. What else do we need? The length of the major axis. Okay, so the length of major is going to be 2 times a. So that's 2 times 5, which gives me 10. And then the length of minor is going to just be 2 times b, which is going to be 2 times 3, which gives me 6. And you can easily find that either by the graph. You can see that you can just count. Really just doesn't matter. Okay? All right. So let's do another problem. So let's say we have the same thing, but we have 9x squared plus 4y squared equals 36. Well, if you have something that looks like this, then now what we want to do is notice that this is not in the proper equation of an ellipse. You want this right-hand side to be equal to 1. So I'm just going to divide everything by 36. Divide everything by 36. So this is going to give me x squared divided by 4 This is going to give me y squared divided by 9. It's going to give me a 1. So notice now that the biggest side is now 9. So this guy now is my a squared. And now this guy now is my b squared. So now what I have is a graph that is vertical. So now it's going to be 3 units up in the y direction. Oops. And then it's going to be 2 units, because that's a square root of 4, up in the x direction. So now my graph looks like this. Okay. So here my vertices are going to change, because now they're going to be on the y-axis. So that's going to be 0, 3, and 0, negative 3. My foci, we're still going to do the same thing. C squared equals a squared minus b squared. So a in this case now is this 3, square it, that's going to give me 9. This now is 2, square, that's going to give me 4. So 9 minus 4 is going to give me 5. So C gives me plus or minus square root of 5. So that means that the vertices are going to be right there. So those points are going to correspond with 0, comma square root of 5 and 0, comma negative square root of 5. So that's what that is going to be. So what will be the length of the major? So the length of the major is just going to be 6, because it's twice this length. So it's going to be 6. And the length of the minor is going to be twice whatever this is, which is going to be 4. Okay. Cool. All right, now let's just do one more problem. Okay, so we want to find an equation for the ellipse that satisfies the given conditions. Okay, and here are the conditions. We want the foci to be 0, comma plus or minus 3, and we want the vertices to be 0 plus or minus 5. Okay, so let's figure out what the equation should be. Okay, so why don't we start off by trying to graph this guy. So the vertices are going to be 0, comma 5. So that means along the x-axis, along the y-axis, you see 0, 5, 1, 2, 3, 4, 5. You can see that the major axis, this is going to be a vertical guy. Okay, so it looks something like this. Okay, we see that the foci is going to be plus or minus 3. So it's 3 here and negative 3 here. That's sort of the foci. So right now, all we just have is the equation x squared over y squared. Okay, so now in this case, which one should be a? Y is going to be the a, because we're seeing that the major axis, the vertices are going to be there. So a squared is going to be under the y. B squared, the minor axis, is going to be under the x. So we're going to have x squared over b squared, which we don't know what that is, plus y squared over a squared. A squared in this case is going to be this number, which is 5 squared. Okay, now we need to figure out what b is. Okay, so all we got to do is think about, well, what relates a, b, and c, which is the foci, because this is c, this is a. Well, we know that the equation of the foci is c squared equals a squared minus b squared. So let's solve for b that way. So I know that c is going to be 3, so that's 3 squared. A squared in this case is 5 squared, and then b squared. So this is going to give me 9 is equal to 25 minus b squared. Subtract by 25. You're going to get negative 16 is equal to negative b squared. Divide out the negatives. B squared equals 4. So, b squared equals 16, which then, in that case, b gives me plus or minus 4. So that means that my equation of the ellipse is going to be x squared over 4 squared. So 4 squared is going to give me 16, plus y squared over 5 squared, which is 25, is equal to 1. So this is going to be my equation of the ellipse. That satisfies these given conditions. Okay.